Having reviewed the Laplace transforms that we're familiar with, I want to show you one new one here before we do some examples with inverse Laplace transforms. The new one is the Laplace transform of a power of t times any function. It's a little bit interesting, unlike the ones we've seen before. But the formula is it's negative 1 to the n, and then it's the nth derivative. Notice that n is the power on t. It's the nth derivative with respect to s of whatever the Laplace transform of f would be. So just like we saw with the exponential one, there's kind of this idea of like a modifier on any other function. So any function times e to the at has one rule for modifying the original Laplace transform, and any function times t to the n, again, you would find the regular Laplace transform of f, and then apply this modification to it. We won't bother to prove this, but you can look in your textbook if you're interested. But we can use it for a couple examples. For example, let's say we have the Laplace transform of t times sine of 3t. So in this example, f of t would be the sine of 3t. So first thing I'm going to do is find out what f of s is, capital F of s. And just by looking it up, b in this case is 3, and the Laplace transform of sine is b over s squared plus b squared. That's just a look up in the table. So now the Laplace transform of the full thing is going to be negative 1 to the n. Notice that n here is 1. We have to have t to the 1. And then times the nth derivative, so the first derivative of f of s. So we'll take that f of s, capital F of s, and take the derivative just using your familiar derivative rules. I will mention that this is one of the harder ones to do an inverse Laplace transform on, to recognize as needing to work backwards. So it shouldn't come up in any examples that we have to do anything like that, because it's just a little bit beyond what's reasonable. All right, so quickly, just taking the derivative of this, you would use either the quotient rule, or you could think of rewriting it as 3 times s squared plus 9 to the negative 1 using the chain rule. Kind of however you do it, what you should end up with is something that looks like negative 3 times 2s over s squared plus 9 squared. And I'll leave it to you to verify that using either the quotient rule or the chain rule. And then just do a little bit of simplification. Notice that the negative 1 cancels with this negative sign here, and we'll combine the 3 and the 2 on the top to make 6s, and we're done. So you do the Laplace transform of t times sine of 3t just by knowing the original Laplace transform and then doing the derivative of it. For another example, let's say we have something like e to the 4t times t to the third. Now, by the way, we wouldn't need this rule necessarily to do this one, because we could use the Laplace transform of t to the third and then apply the exponential modifier to it, and we would get the same answer we're going to get in just a second. But just for the sake of showing you an example, we're going to do this one using this new rule. So we're going to think of this exponential part as f of t. So just like before, we're going to find capital F of s. Again, just by looking it up in the table, that's 1 over s minus a. A in this case is 4. So 1 over s minus 4. Now if you look back at our formula here, we need to take the nth derivative of this transform. So we've got t to the third, so we need the third derivative. So the first derivative, again, I'll go through these quickly. I don't think you need time reviewing derivatives at this point, but if you want to pause and do these on your own just to practice, feel free. The first derivative is negative 1 over s minus 4 squared. The second derivative is 2 over s minus 4 to the third. And then the third derivative is negative 6 over s minus 4 to the fourth. So then we're ready to go. We can take this Laplace transform. So it's going to be negative 1 to the n, and in our case is 3, then times the third derivative of 1 over s minus 4. We know what that third derivative is. We found it down here. So that's going to be negative 1 to the third is negative 1, and then times negative 6 over s minus 4 to the fourth. The negatives cancel, so simplifying gives us 6 over s minus 4 to the fourth. Now again, we could have done that using the exponential modifier on t to the third. We would have gotten the same thing, but again, it's nice to have multiple ways to get to the same answer.